If you've spent any time online lately, you've probably been hit with terms like AI, machine learning, and deep learning. It is easy to get the feeling that they are all describing the same thing, but they actually have very specific places on the map. To find our way, we are going to build a visual guide, starting at the very center with artificial intelligence. At its simplest level, this is a computer program attempting to mimic human thinking. This idea grew out of a specific goal in the 1950s, led by a computer scientist named John McCarthy. From that center, we can draw our first branch, General AI. This would be a machine that is as adaptable as a human being. Currently, this does not exist. Our second branch is Super AI, the kind of intelligence that surpasses humans entirely. This is a popular theme in movies, but in our world, it remains purely hypothetical. That brings us to this third branch, Narrow AI. This is where all current technology lives. These are programs dedicated to doing one specific, limited task very well. Everything you use today, from the filter that catches your spam to the voice assistant on your phone, belongs to this single branch of Narrow AI. If we follow that branch further, we reach machine learning. In the past, programmers had to write every single rule for a computer to follow. Machine learning changed that by feeding a system massive amounts of data and letting it find the rules for itself. There are three main ways a machine learns. The first is supervised learning. This works like a set of flashcards. We give the computer thousands of examples that humans have already labeled, like red or green, until it learns how to tell the difference and sort new items correctly. The second way is unsupervised learning. Here, we give the computer data with no labels at all. The computer looks at the raw information and discovers its own patterns. It might notice that a group of customers all buy similar products at the same time, even if we never told it what to look for. The third way is reinforcement learning, which is a system of automated trial and error. It works like a video game. When the computer makes a mistake, it gets a penalty. When it gets closer to its goal, it gets a reward. It tries again and again and again, until it finds the path that earns the highest score. No matter which exact path it takes, the machine is constantly using that feedback to adapt and improve its performance. If we zoom even deeper into machine learning, we find a specialized core called deep learning. This structure is inspired by the human brain. Information enters an input layer, travels through a complex web of hidden layers, and comes out the other side as a finished result. For a machine to learn this way, it needs an immense amount of data to study and significant computer power to handle the complexity. Because the middle layers perform millions of tiny calculations all at once, we often run into the black box problem. The computer gives us a correct answer, but its internal logic is so complex that humans cannot easily see exactly how it made its choice. At the very heart of that deep learning core is the specific technology you likely see every day, Generative AI. While most AI looks at data to sort it or make a prediction, Generative AI uses its training to build completely brand new content, like text, images, or code that did not exist before. This creation is made possible by a design called a transformer. Think of it like a chef with a bag of mixed groceries. The machine looks at a prompt, identifies how the individual pieces relate to one another, and transforms them into a single meaningful meal. Our tools have historically spent their time organizing the world around us. Now they are helping us build it. Pulling the camera all the way back shows us the full map we have just built. The oldest tools on this map were machines that simply lived in the moment. Systems like IBM's Deep Blue could beat a human at chess, but they had no memory of past games. They only saw the board as it existed right then. We have since moved to machines that can look at the immediate past. A self-driving car stays safe by remembering the position of the vehicles around it from a few seconds ago to decide its next move. Even with these massive leaps in capability, everything we have built so far, from chessbots to self-driving cars, is still part of that same narrow AI branch. AI is often presented as an unsolvable mystery, but it is actually a logical structure of data and learning layers. And now that you have seen the map, you can